back here doing lesson 11-7, page 617, number 12. This is a subtraction problem, and as we look at this, we notice a couple of things. One, they do not have the same denominator, so we're going to have to work with that. And the other things are fine, though. We have an x here, we have an x minus 2, that's fine, the 3 is fine, but right here, we need to factor this trinomial before we can do anything else. So let's go ahead and do that. Remember that the negative 10 at the end goes at the top of this diamond, and we're going to try and find two numbers that we can multiply to get negative 10. We also put this positive 3 down here at the bottom, and we're going to try and find two numbers that will add up to number 3. So it's the same, has to be the same two numbers. So when you think about that, well, you go, okay, how are the ways that I can multiply and get 10 or negative 10? Well, we start off with, how about 2 times 5? But then we know it has to be negative, and we also want it to come out as a positive here. So if we do this, we get negative 2 times 5, which is negative 10, and then negative 2 plus 5, which gives us the 3. So those are the two numbers that will work right there. So I'm going to cross out this trinomial right here, and I'm going to rewrite the same thing, but just a different way. And that's going to be two sets of parentheses. The first thing in each parentheses is going to be this x right here. So we'll put the x here, and we'll put the x here. Then we're going to use these two numbers that we got from the diamond method and put them over here. So we have minus 2, and we have plus 5. So we just put them in there. Now this is completely factored, and we're going to start looking around for things that we can cancel out top and bottom. All right? But before we do that, we have one other thing that we have to do. Take a look here at this denominator. It's x minus 2 and x plus 5. Over here we just have x minus 2. So you can see that both sides have x minus 2, but only this side has x plus 5. That means that if we want the denominators to be the same, it has to be the same here and here. So the way to do that is to take your x plus 5 and bring it over and multiply it, top and bottom, like this. And you have x plus 5 and x plus 5. That's how you get the denominators to be the same. You can see I'm pointing the two denominators are the same. Doesn't matter if they're in opposite order, but it's the same two pairs there. So now we have to multiply across the top, and remember this is a subtraction here, and then we're going to have our next look at this problem. Let's go ahead and put the denominator on the bottom. It's the same here and here, so I'll just write it down this way. X minus 2, right here, times x minus 5. I'm sorry, x plus 5, right there. So, now for the top, here's what we have to do. We have to distribute here, and we're going to do x times x, which is x squared. And we're going to do 5 times x, which is 5x, so we put plus 5x right here. Then we have the minus sign right here, so we put minus, and then the 3 that we have. So now we have that on the top, having combined everything that was up on the top. We have the denominator on the bottom, but now we're looking at a trinomial again. Usually what we want to do is try to factor the trinomial. Well, let's try that here, because if we can factor it, then we're going to be able to maybe use that at the end of the problem. So we try this. We go another diamond method right here. We put the minus 3 at the top. We put the 5 at the bottom. And we try to find two numbers that when you multiply them give you negative 3, and when you add them give you a positive 5. Well, if you think about that, really there's going to be no way to get the numbers that you need for this, because all you can do here is 3 times negative 1 or negative 1 times 3 to get the negative 3. Neither one of those will add up to 5. So I put question marks here. It's not going to work. Can't do it. So that means that we're not going to be able to rewrite this as two pairs like we might have in other cases like we did here. We're not going to be able to do that here because we don't have the numbers that we need. And that means that we will just use the answer as it is, like this. You can't do any more, and you say that is our final answer. And so that's what happens when you cannot factor one of the trinomials. There you have it.